Good afternoon, students. My name is Bhrugupati, and I am an graduate from IIT Kharagpur from 2016 batch. Today we will study about physics, and we will have an introduction to physics. We will have a basic introduction to physics. So, when you hear the word physics, what comes into your mind? So the first question you might be having is that what is physics? So when you are waking up in the morning, you can see the sun coming up, and in the night the moon is also coming up. So the sun and moon are revolving. The planets are revolving around the sun. So there are a lot of natural phenomena going on in the world, and around you, you might be seeing that when we are kicking a football, while you are playing football, the football is not going up continuously, but it is coming down after some time. So why it is coming down, and how the apple is falling from the tree, or the orange is falling from the tree? So, if you know the Newton's laws of motion and Newton's laws of gravitation, you will definitely understand how all these natural phenomena are happening. So, physics is just that. In physics, what we are trying to do basically is we are trying to understand the physical phenomena and also understand uh, the laws through which the physical phenomena is happening. So understand the physical phenomena and laws governing it. So this is physics. To understand the physical phenomena and laws governing it, like when the apple is falling or orange is falling, why it is falling? What is the law that is governing because of which the apple is falling? How the nature is working? And when we are kicking a football, or when you are striking a tennis ball, how it is going in this way, or it is going smoothly, straightly. So you can understand by understanding the laws governing it. Like if we strike this way, the ball will go this way. So there is an understanding behind it, and by physics, through physics, we can understand the laws governing physical phenomena around us. So someone is playing chess and you don't know the rule, and you are just watching the game of chess, and while observing the game, what happens is that you can derive that the elephant goes diagonally, or the sheep goes straight way. So just by watching the process, you can understand, and you can understand the laws through which the game is happening. So similarly, this whole world is a game, and there are many natural events happening in it, and by observing the natural phenomena, we can understand the laws of nature, or laws of physical phenomena, and we call this as physics. So there are many scientists like Newton. He discovered by observing that the apple is falling towards the earth, and he also observed that the planets are revolving around the sun. So by observing the natural phenomena, he came into a theory or law by which the phenomena might be happening. And if it is true for all the processes, we take it as a law. And if in the future this law doesn't work, so we just put it in the dustbin and we follow the new rule through which everything will be happening. Similarly, when you go into the science, when there is a model of atom, first it was a pumpkin model, then electrons started revolving around it, and when you will go further to higher studies, you will see there is electron cloud around the nucleus. So as you go deeper into the process, you will find what you realized before is actually not true. So you drop it and you follow the new rule. So physics also happens like this, and there is a relation between physics and mathematics. So what is the relation between physics and mathematics? Whenever you are studying physics, there is the need of mathematics. Like for the gravitational force, you can define it as the force of attraction between two masses. Gravitational force can be defined as the product of two mass and divided by the distance between them. But we can simply express it as F is force of gravitation is directly proportional to mass 1 and mass 2, and it is inversely proportional to distance between them. So we can simply write it as a mathematical expression. But if we will be defining it in long sentence, it will be very tiresome and it will take a lot of time. Secondly, mathematical expression makes it easy to understand, and it helps us to solve many problems having the same situations. So by using this formula, we can understand the many things, like how the moon is revolving around the sun, and moon is revolving around the earth, and earth is revolving around the sun. And in a similar way, we can apply this for many things. So mathematical expression is very much useful. Secondly, there are things like derivatives, sorry, not derivative, it is differentiation and calculus. It is called calculus. It let us understand if the velocity is like this, changing this way, what is the acceleration. So by differentiating velocity with respect to time, we can get acceleration. So rate of change of velocity with respect to time is called acceleration. So calculus also helps us to solve a equation, and there is integration and there is trigonometry. So mathematics is basically the language of physics. It is like when I am trying to explain, I am using English as a language, or else how I will explain it to you. So to explain physics, we use mathematics as a language. Mathematics is not actually physics, but we are using it to express ourselves. So mathematics is the language of physics, and we need the basic mathematics to understand physics in a deep and more clear way. After this, we will go to the section of units. Okay. So what do you mean by units? Like to compare something, we need units like I have 1 kg of rice and I have 10 kg of rice, or I have 1 kg of mango and I have and the rock is 100 kg. So we are comparing their masses, weight. So to compare we use units because one thing is larger than other, and how much larger it is we can we have 1 kg of rice and 10 kg of weight. So there is a amount and there is a definite amount for 1 kg of rice and there is a definite amount for 10 kg of wheat, and we are comparing it through mass. We can also compare them by volume. We can compare by mass, we can compare by volume. So in a similar way we can compare. So these are one quantities. So to express these quantities we are using some unit. For volume we use liter or we use meter cube. So these are two different types of units for volume. Similarly for mass there is the unit of kg and also unit of gram. And similarly there are different types of unit. For length we use different types of units, like we use meter, we use centimeter, we also use feet, we also use inch. These are different types of units of length. So we have lot of units to compare one thing from another. And if we have so many of units, then we will be getting confused. So there is a standard unit called SI units, and its full form is International System of Units. So the whole world follows a international system of units called SI units, and it is it is decided by a conference called CGPM. So the full form of this CGPM is called General Conference on Weight and Measures. So this CGPM is General Conference on Weight and Measures. So it basically decides the standard units or SI units of different types of quantities. And there are many units, but there are some standard or fundamental units, or we call them base units. Fundamental or base units. Fundamental or base units in SI. These units are decided by CGPM as a standard fundamental units, and there are 7 types of base units. So what are these base units? What do you mean by base units? Base units are called the fundamental quantities which are independent of each other. They should be independent of each other. And other units other units of other quantities are defined by these fundamental or base units. So base units are independent of each other, and other whatever other quantities are there, they are represented in form of base units. So we will see there are 7 fundamental units, and these are called length, mass, time, electric current, and thermodynamic temperature, and we have amount of substance, and we also have luminous intensity. So length is the fundamental quantity, and its SI unit is meter, and it is written as M. Similarly, these are fundamental quantities, and these are their SI units. So the fundamental quantity is length, and its SI unit is meter. The second fundamental quantity is mass, and its SI unit is kilogram, and it is written as kg. The third fundamental quantity is time, and its SI unit is second, and it is written as S. The fourth one is electric current, and its SI unit is ampere. The fifth one is thermodynamic temperature, and its SI unit is Kelvin, and written as capital K. And the amount of substance, which is also a fundamental quantity, like how much substance is there. So for it, there is also a also a SI unit. It is called mole, and it is written as MOL, mole. And there is luminous intensity, like how much intensity a light is providing, how much illuminating it is. So to measure it, we use a quantity called luminous intensity, and it is its SI unit is candela, or written as CD. So we have the 7 fundamental quantities or base units, and all other quantities can be written in form of these fundamental quantities, and those are called derived quantities. So these derived quantities are dependent on these fundamental quantities. So let us see an example of derived quantity. So let's say velocity. What is velocity? Velocity is rate of change of distance per unit time. How much distance you are covering per unit time. So what is the unit of distance? It is distance is length, so it can be written as L divided by, and time is also a base unit. So velocity which is a derived quantity, can be written in two fundamental quantity. One is length and another is time. It can be expressed in two fundamental quantities. Similarly, acceleration is rate of change of velocity, change in velocity divided by time. So what is velocity? Velocity is L by t, and we have divided by time. So acceleration can be written as L divided by t square. So acceleration can also be represented in two base quantities, length and time. So this is the concept of units and why it is used, and you can relate all these things into your daily life to understand it in a much better way. And if you have any doubt, you can post your questions in comment section, and I will answer them in the next class. So there are some prefixes like uh, we say no, like if 1 lakh can be written as 10 to the power 5. So 10 to the power 5 is called, or if we take another, it can be written as 10 to the power 6, and this is called 10 to the power 6 is called mega. So to express something in form of the power of 10, we have various nomenclature to say them. So exa means 10 to the power 18, peta means 10 to the power 15, tera means 10 to the power 12, and so on. We have giga, mega, kilo. Kilo is actually 10 to the power 3. Then hecto and deca is 10 to the power 0. Okay, sorry, 10 to the power 1. And after that there will be negative power coming up, like centimeter. It is centi. Centi means 10 to the minus 2, and nano means 10 to the power minus 9. Micro means 10 to the power minus 6. Micro comes in between them, 10 to the power minus 6. So these are SI prefixes. So we call them SI prefixes. To shorten a longer mathematical expression, we use them like this. For example, speed of light is 299,792,458 meter per second. Okay. So we can write this as 2.9 into 10 to the power 8 meter per second, or we can approximate it as 3 into 10 to the power 8 meter per second. So instead of writing this longer expression, which is not necessary for calculation, we write it in SI prefixes like 3 into 10 to the power 8 meter per second. So these base units are decided definition of base units or fundamental units. So when we are defining base units, we are keeping in mind two things. First one is invariability. Invariability, and second one is availability. So base unit should be invariable, like it should not change from one place to another place. So it should be always constant wherever we go. It should be constant. It is one of the property of base unit. While we are defining it, we define it in such a way that it remains constant. It doesn't change with time, and it should be available wherever there is necessary. For any quantity, we can use it. So these two things are kept in mind to define the base units. For length, 1 meter is defined as the distance traveled by light in vacuum in 1 by 299,792 for 58 second 58 second. So whatever the distance light travels in this much second, we call that distance as 1 meter of distance. So we know that the speed of light is fixed, so this doesn't change. This is the speed of light is 299,792 for 58 meter per second. So in 1 second it is going that much meter. So in 1 by 299,792 for 58 second, it will go how much distance? It will go 1 meter. Okay. So similarly, there are some generally the procedure to define a standard value as a unit are quite often not very simple and use modern equipments. For example, a second is 1 second. 1 second is defined by the radiation of cesium 133 isotope. So the radiation of cesium 133 isotope is studied in a laboratory, and through that we are defining 1 second. So because of this, the definition becomes complicated. So all these things are defined in CGPM by CGPM through different procedures. Similarly, like kilogram, how the kilogram is defined: the mass of a cylinder made of platinum iridium alloy kept at International Bureau of Weights and Measures is defined as 1 kg. So you don't know the International Bureau of Weights and Measures, but over there is a laboratory where they have kept a platinum iridium alloy cylinder made of platinum iridium alloy, and the mass of that platinum iridium cylinder is called 1 kilogram. So it is actually decided by we all humans or by some conference, international conference, which is followed by everyone. So we have the definition like this, a standard definition like this. We are taking a standard definition because length has different units like inch, feet, meter, centimeter. Similarly, there are many units. So everywhere people may use different units. but if we will use different units, then while communicating with each other it will be difficult. So there is a standard system of units which is followed by everyone for easier of understanding. So Kelvin is also defined like that the fraction 1 by 273.16 of the thermodynamic temperature of triple point of water is called as 1 Kelvin. So all these definitions are not important. You can just understand that these are defined by all humans by through a conference, international conference, and it can be changed. Few months back, there was a news that the 1 kg, the quantity 1 kg is changed slightly, and there is a new definition for 1 kg of mass. So it may change according to the changes in the international conference. So after this, we will go to the section called dimension. Dimensions. Okay. So we saw that any quantity can be expressed in terms of what? In terms of base quantities. We saw by example that velocity is a quantity, but it can be expressed in form of what? Length and time. Length and time are two base quantities. So the power of length is 1 and time is 1. In case of acceleration, what we saw that it can be expressed in form of L divided by T square. So it is written as L to the power 1, T to the power minus 1. It can be written as L to the power 1, T to the power minus 2, and M to the power 0 if you want. Power, if 0 is the power, what is the value of this? Value of this is 1. So it has no meaning actually. So we are taking the power of mass as 0 because it is 1 ultimately. So whatever is the power of those quantities, base quantities, we call that as the dimension of that physical quantity, that base quantity. So here, what is the dimension of length? The dimension of length is 1. The dimension of time is minus 1. The dimension of mass is 0. Similarly, for acceleration, in acceleration expression, the dimension of length is 1, the dimension of time is minus 2, and the dimension of mass is 0. So, dimension is basically it is the exponent of the base unit. Exponent of the base unit. Exponent of the base unit when any quantity is expressed in form of base quantities, like velocity expressed in form of length and time similarly. So if we see force, what is force? Force is equal to mass into acceleration. Mass is a base quantity, so we let it be like this. What is acceleration? It is length divided by time square. So here we have L to the power 1, T to the power minus 2, M to the power 1. So here, over here, mass has the dimension 1, time has the dimension minus 2, length has the dimension as 1. So similar way you can understand by looking at the dimension of force that there is a extra dimension of 1, extra dimension of mass here, but here the dimension of mass is 0. So the difference in dimension between acceleration and force is in only mass. In case of force, the dimension of mass is 1, and in case of acceleration, the dimension of mass is 0. So there are various uses of dimensions. We will see some quick uses. So here, first use is homogeneity of dimension in an equation. To check the homogeneity of dimension in an equation. So what do you mean by this? So there is some expression, let's say S is equal to ut plus half a t square, where s is the distance. So what is the dimension of distance L, and what is the dimension of u? U is velocity. This is the formula. You will know later if you don't know. So we are just giving an example. We are taking this equation. So in left hand side, homogeneity of dimension means whatever is the dimension in left hand side, that should be the dimension in right hand side. So that dimension in left hand side should be equal to dimension in right hand side. Then this equation will be correct dimensionally. If a equation is not correct dimensionally, that means that equation is wrong. So you cannot use it. So here we are experimenting upon this. Left hand side, the dimension is L to the power 1. So right hand side, u is length per unit time. This is u is velocity. Velocity is L by t into t. T is time plus half. Acceleration is length divided by time square. Just few minutes before we study, and we have this t square. This t square will cancel out. This t will cancel out. So L plus L. This dimension will be L. So we have the dimension at the left hand side is equal to the dimension at the right hand side. So this equation is correct in a way. Dimensionally this equation is correct. So any equation should be homogeneous if it is a correct equation. So if we need to check if some equation is correct or not, we can check it by dimensional analysis. So we will check what is the dimension on left hand side, and we will again check the dimension on the right hand side, and we will see if left hand side dimension is equal to right hand side dimension or not. And if it is and if it is correct, then the equation is dimensionally correct. The second use is conversion of units. So in SI unit, let's say SI unit, we take the SI unit of pressure is Pascal, is equal to Pascal. So pressure is equal to what? Force per unit area. Okay. So pressure P can be written as force is what? The dimension of force is M L T to the power minus 2. We did this sometime before, and the dimension of A is L square. Okay. So the net dimension will be M into this one will cut. So it is dimension 1, it is 2. So there will be minus 1 dimension of L to the power minus 1 and T to the power minus 2. So this is the dimension of pressure. Now we want to change it from one form of unit to another form of unit. So Pascal is its SI unit, and there is another kind of unit called CGS unit, where the standard units are taken as 1 centimeter, gram and second. Okay. In CGS system, we take the base units as centimeter, gram and second. In SI unit, we take it in SI. We take it as meter, kilogram and second. Okay. So we will convert it from SI unit of pressure to CGS unit of pressure. So 1 Pascal is equal to 1 kg into 1 meter to the power minus 1 here. We are just putting it, and 1 second to the power minus 2. 1 CGS pressure is equal to 1 gram to the power 1 and 1 centimeter to the power minus 1 and 1 second to the power minus 2. Now we are dividing 1 Pascal divided by 1 CGS pressure. So if we divide 1 kg by 1 gram, it will be 1 meter by 1 centimeter and 1 second by 1 second to the power minus 2, to the minus 1. So it will turn out as 10 to the power 3. 1 kg by 1 gram is equal to 10 to the power 3, and 1 meter by 1 centimeter is equal to 10 to the power 2, 10 to the power to the power minus 1. So it is equal to 10. So what we got here? We got here that 1 Pascal is equal to 10 times of CGS pressure. So whatever the CGS pressure, it is 1 Pascal is equal to 10 times of whatever is the CGS pressure. So Pascal is 10 times more than the the unit of CGS pressure. Whatever is the basic unit, it is 10 times more. Pascal is 10 times more than the CGS pressure unit. So we have converged. We used the dimension to conversion of units from SI unit of pressure is Pascal, and CGS into CGS unit. Third use is deducing relation among the physical quantities. Deducing relation among the So we also use for to deduce relation among the physical quantities. We will see an example. Suppose we take a pendulum. What is pendulum? We hang a ball from here through a string. Let's say its length is L and its mass is M. There is a gravity acting upon it. So it will oscillate like this. So the time period of pendulum, it may depend upon what? Length of the string. How much it depends, at what dimension it depends, we don't know. So we take it as A, and for M, let's take it as B, and for it also depends on gravity. So let's take it as acceleration of gravity. Let's take it as C, and we take a dimensionless constant K. So here the power is 1 because we are taking it. We are finding the time period of a pendulum. Time period means time. So time period can be expressed as K, some dimensionless quantity, into L to the power A. It may depend upon the length of the string. M to the power B. We don't know how it depends, so we took an unknown variable A, and upon mass M as, and we don't know how it depends, so we took it as B, and we took it as C for acceleration of gravity. But we know here the dimension of time is 1. So at left hand side we have t to the power 1 as dimension. On right hand side what we have? Length to the power A, mass to the power B. G is basically acceleration, so length per time square to the power C. So if we simplify this, it will be what it will be? It will be L to the power A plus C, M to the power B, and T to the power minus 2C is equal to T to the power 1. So here A plus C is equal to 0 because we can write it here as L to the power 0, M to the power 0, T to the power 1. This left hand side dimension, we can write it as like this because this is 1, this is also 1. So we are comparing the dimension. A plus C is equal to 0, B is equal to 0, minus 2C is equal to 1. This implies that C is equal to minus 1 by 2. We got one thing. And A plus C is equal to 0. This implied that A is equal to minus C is equal to 1 by 2. So what from this equation, what will, by putting the value of ABC here, what is the time period of a pendulum? Time period of a pendulum is equal to K into L to the power A. L to the power A means 1 by 2, M to the power 0, and G to the power what? C is minus 1 by 2. So it is basically becoming M to the power 0 is 1, So let's cancel it. It is L by G root over. The time period of a pendulum is K into root over L by G. So K is a constant, and now we found out how the time period of a pendulum, the equation of time period of a pendulum uh, by dimensional analysis. So we deduced the relation between physical quantity, between by deducing the relation between them, we found out the time period of a pendulum. So we can also use dimensional analysis in this way also. But there are certain limitations in dimensional analysis. These are uses and there are certain limitations. So limitations. Limitations of dimensions. Dimensional method. So first limitation is what? It works only for product type equation. So S is equal to ut plus half a t square. Here we have a summation type equation. This is not product type equation, but we saw the product type equation, that is time period of a pendulum as root over k into root over L by G. So this is a product type equation, so we were able to derive this equation, but we cannot derive this equation by dimensional method because this is a summation type of equation and there will be problem in evaluating, in comparing the dimension. Secondly, we cannot find the numerical constant. We cannot find the value of numerical constants as they are dimensionless. Here k is a dimensionless constant, but we do not know it is some constant, but by dimensional method we cannot find out its value. So that is the second limitation. The third limitation is the method works, the dimensional method, the dimensional method works only if there are as many equations available as there are unknowns. So if the number of equation and number of variables are not same, then we cannot solve the equation by dimensional method. So it is its third third demerit. So here we are ending the dimensional method. So introduction of physics ends here. In the next chapter we will study about physics and mathematics, like what are the mathematical things, basic things you need to know, so that you will be easily it will be easy for you to understand the physics, because there are many things like vector algebra, vector representation, how to add vector, how to subtract vector, the dot product between two vectors, the cross product between two vectors. There is calculus. Calculus means differentiation and integration. We will see some basic formulas, and there is trigonometric formula. It is very much essential to solve cosines and sine functions. So we will see these things in the next chapter. So at the end of the session, we can see that physics is very much wonderful. It describes a lot about our world. It describes how things are working around us, what are the laws through which the world is happening, and it gives us a lot of joy when we know something. When we know the laws through which the physical world is working, we can design our instrument to fly against its odds. Like the aeroplane is designed by understanding the laws of physics, how birds fly, by looking at them, by observing them. People were able to build aeroplanes. Also, there are many things like engine is going on. So all these things are studied and understood through physics, and people have used that to bring forth technology which directly affects our life. Like in old days, people used to walk from one point to another point. It is difficult if you walk from Bhubaneswar to Delhi. It will take many days, but because of technology, we are able to reach Bhubaneswar to Delhi in 2 hours if we go through flights, and we can reach there over 24 hours, by 24 hours. If we go by train, or we can use our own vehicle, cars or motorcycle. So all these things came by understanding physics, how the natural phenomena work. So if you want to build something, or if you want to invent something of your own, so you need to understand how things are working. You need to observe, you need to evaluate, you need to understand them. So in order to understand all these things, physics is very much necessary, and physics is the study of all these things. So when you study physics, it will give you a lot of idea how the moon is rotating around the earth, how the earth is rotating around the sun, and so on, and a lot of things, how the sky is blue, how you are able to, like in science, you must have studied that why it is looking blue, the writings, because when light is falling upon it, white light, this ink is observing everything and reflecting only blue color, so that the blue color is reaching your eyes and you are able to recognize it. So when you understand it, there is a sense of calmness, and there is a sense of joy within you. So the world is magnanimous. There is atom, hydrogen atom is 10 to the power minus 10, of the order of 10 to the power minus 10, and the diameter of sun is 10 to the order of 10 to the power 9, and the difference between them is 9 minus 10, it will be around 19. So sun is around bigger of the order of 19, 10 to the power 19 than a hydrogen atom. So in a similar way you can understand all these things, and it will give you a lot of joy, and if you are filled with wonder, physics is the thing to go. And when we go through different sessions, you will find it more joyful and wonderful. So I am stopping here. The next time we will see we will understand and learn the language of physics, that is mathematics. Namaskar. See you in the next session.